Hi everyone. So today we're doing the exercise number 2.5 from the chapter Polynomials in Class 9 Mathematics NCERT. So let's go right ahead. The first question of the exercise is asking us to use suitable identities to find the following products. Now, throughout this exercise, we're going to have to use a lot of these properties, and I've listed them out on the top right hand side of the screen over here for easy reference. It's going to turn out to be really helpful for us. Now, the first part is x plus 4 multiplied by x plus 10. This product looks very similar to property number 4 over here, x plus a into x plus b, which gives x square plus a plus bx plus ab. So out here, when we use it in our question over here, a is equal to 4 and b is equal to 10. So we can expand this as x square plus 4 plus 10 into x plus a into b, 4 into 10, which is 40. This gives us x square plus 14x plus 40. And that's the expansion. Moving to the second part. The second part is x plus 8 multiplied by x minus 10. Now this is also similar to identity number 4 over here. However, don't get confused by the minus sign out here. We can simply take x minus 10 to be represented in this way. X plus of minus 10. So now when we compare this to our identity number 4, a is equal to 8 and b is equal to minus 10. Now this looks like our property and we can expand it. So this gives us x square plus 8 minus 10 into x plus 8 into minus 10. This is equal to x square minus 2x minus 80. And that's the product. Third part is 3x plus 4 multiplied by 3x minus 5. Out here again, we'll draw similarities to identity number 4. Out here, however, I will just indicate this with a different color. Now, from the identity, x over here is 3x. A in this case is 4, while b in this case is minus 5. Now, if we use these and use identity number 4, we get x square. In this case, it will be 3x whole square plus a plus b into x. So here we have 4 minus 5 into 3x, which is behaving as x over here, plus a into b, which is 4 into minus 5. And therefore, I can write this as 9x square minus 3x minus 20. And that's the expansion. The fourth part is the product of y square plus 3 by 2 and y square minus 3 by 2. Can you guess which identity does this look like? So I'm drawing parallels over here with identity number 3. It may not be obvious with the x square minus y square over here, but notice the right hand side. The right hand side is the product of x plus y into x minus y. Out here, our x is behaving like y square, whereas y in the property is behaving like 3 by 2. And hence, when you expand this, I should get x square minus y square. So which is y square the whole square minus y square, and in this case this is 3 by 2 square. So this gives me y to the power 4 minus 9 by 4. I could also write this as 4y to the power 4 minus 9 whole upon 4. Both of them would be the correct representation. The fifth part is the product of 3 minus 2x multiplied by 3 plus 2x. Now out here again, I'm drawing parallels with identity number 3 out here, and the right hand side of it rather. X from my identity is the number 3. Y from the identity is 2x. So this gives me 3 square minus 2x whole square, which is 9 minus 4x square. And that's the product of the fifth part. Now moving to the second question, it's asking us to evaluate the following products without multiplying directly. And we'll see how we do that. The first part is 103 into 107. Now we can use the help of our identities over here to make this multiplication without actually directly multiplying it. But first we need to represent this in a different way. I can write 103 as 100 plus 3 multiplied by, I'll write 107 as 100 plus 7. Now we can see that this looks a lot like identity number 4, x plus a into x plus b. And when we expand identity number 4, we get x square, in this case it's 100 square, plus a plus b into x plus a into b. So out here, I get 10,000 plus 1,000 plus 21, which is nothing but 11,021. And if you want to directly multiply, we can also do that and check, we'll get the same answer. However, we were able to do this with the help of the identity. We're going to try the product of the second part, which is 95 into 96. The representation for this product we'll write as 100 minus 5 into 100 minus 4. And here again, we're going to expand this using identity number 4. So we'll get 100 square plus minus 4 minus 5 into 100 plus minus 5 into minus 4. This gives us 10,000 minus 900 plus 20. This can be written as 9120 or 9120. Now again, we can directly multiply 95 into 96 to cross check whether we get the same answer, and most definitely we will. Moving to the third part. The third part is 104 into 96. I'm going to represent this as 100 plus 4 multiplied by 100 minus 4. This is also similar to one of our identities. Identity number 3, or the right side of it. So this gives us 100 square minus 4 square, which is 10,000 minus 16, which is 9,984. Again, if we multiply these two directly, we'll get the exact same answer. Moving on to the third question. Third question is asking us to factorize the following using appropriate identities. And the first part over here is 9x square plus 6xy plus y square. Now this polynomial I can probably rewrite as 3x whole square plus y square plus 2 into 3x into y. Does this seem familiar to you? This is very similar to identity number 1. From the identity, x is behaving like 3x, y is behaving like y itself. And therefore, when I factorize this, it will factorize to x plus y whole square, or rather in this case, 3x plus y whole square, which is the solution. The second part is 4y square minus 4y plus 1. Now out here, I'm going to take the squared y term of this polynomial and try and make a perfect square out of it, which is 2y whole square. I'll fit 2y into the term with the y in it. So this gives me minus 2 into 2y into 1. And the last term 1, I can simply write as 1 square. It means the same thing. Now this is very similar to identity number 2, where x for me is behaving like 2y and y is behaving like the number 1. And hence x minus y whole square can be written as 2y minus 1 whole square. That's the factorization for this. The third part of this question is x square minus y square by 100. If I am to write these in their perfect squares, I will get x square minus y by 10 whole square. I can use identity number 3 over here, which is of the similar kind, and write this as x plus y by 10 multiplied by x minus y by 10. And that solves question number 3 for us. Moving to question number 4, it's asking us to expand each of the following using suitable identities. First part is x plus 2y plus 4z whole square. This is a fairly standard use case of identity number 5. We're using this identity for the first time in this exercise. So we get x square plus 2y whole square plus 4z whole square plus 2 times x into 2y plus 2 times 2y into 4z plus 2 times x into 4z. And just expanding all of these and opening the brackets, I get x square plus 4y square plus 16 z square plus 4xy plus 16 yz plus 8 into xz. That gives us the solution. The second part is 2x minus y plus z whole square. Now this again is a use case of identity number 5. Again, don't be confused by the minus sign here. I can simply write this as plus of minus y, and my y term becomes minus y. Rest everything remains the same. So let's expand this. We get 2x whole square plus minus y square plus z square plus 2 into 2x into minus y plus 2 into minus y into z plus 2 into 2x into z. When I open all the brackets, I get 4x square plus y square plus z square minus 4 times xy minus 2 times yz plus 4 times xz, and that's the expansion. So if you notice, any 3 terms adding or subtracting, whether it has a plus sign or a minus sign, I've simply used identity 5 and I have put it in a way that the signs take care of themselves. I will just consider the minus sign to be plus of a minus quantity. And it's as simple as that. Now we have the third part of question number 4. It is minus 2x plus 3y plus 2z whole square. Again, just like we did in the previous part, we know that the signs will take care of themselves. We'll expand it using identity number 5. So we get minus 2x whole square plus 3y whole square plus 2z whole square plus 2 into minus 2x into 3y plus 2 into 3y into 2z plus 2 into minus 2x into 2z. Opening the brackets, we get 4x square plus 9y square plus 4z square. The fourth term out here will be minus 12xy. The next one is plus 12yz. The last one is minus 8xz. And that's the final expansion for part number 3. Part number 4 is also similar. We have 3a minus 7b minus c whole square. We'll use identity number 5 here once again, which gives us 3a whole square plus minus 7b whole square plus minus c square plus 2 times 3a into minus 7b plus 2 times into minus 7b into minus c plus 2 times into 3a into minus c. And opening all the brackets, we finally get 9a square plus 49b square plus c square minus 42ab. Over here it will be plus, since minus and minus will be plus, 14bc minus 6ac. That's the solution for part number 4. Part number 5 is minus 2x plus 5y minus 3z whole square. We're pretty used to using identity number 5 over here. We make this minus 2x whole square plus 5y square plus minus 3z whole square plus 2 times minus 2x into 5y plus 2 times 5y into minus 3z plus 2 times minus 2x into minus 3z. Expanding the brackets, we have 4x square plus, sorry about that, 25y square plus 9z square minus 20xy minus 30yz plus, since the minus and minus cancel out, 12xz. This is the final expansion for part number 5. Part number 6 is 1 by 4 into a minus 1 by 2 into b plus 1 whole square. A simpler way to write this is just a by 4 minus b by 2 plus 1 whole square. And we'll use identity number 5 once again to give us a by 4 whole square plus minus b by 2 whole square plus 1 square plus 2 times a by 4 into b by 2 plus 2 times b by 2 into 1 plus 2 times a by 4 into 1. Just a slight mistake here. In these two terms, we have minus b by 2. I almost made a mistake over here. We need to be careful with the signs when we are using this expansion. Moving on, we have here a square by 16 plus b square by 4 plus 1 minus of, here the 2's cancel out, so here we have minus a into b by 4, the 2's will cancel out here as well. I get minus b plus a by 2. We could leave it like this, or we could take this entire polynomial on the base 16 to get a square plus 4b square plus 16 minus 4ab minus 16b plus 8a. And that's the expansion for the 6th part. Now we move to question number 5, asking us to factorize two polynomials, the first of which, I'll write it out, it's 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now out here, let's convert the squared variables as perfect squares along with their coefficients. This is a perfect square of either 2x or minus 2x, could be both, and I'll leave this thought in your head for a second here and move on. Similarly, this can be the perfect square of either 3y or minus 3y, as this can be the perfect square of either plus 4z or minus 4z. Now when I come to the next terms, you can probably see where I'm going over here. I have drawn parallels to identity number 5, and I'm trying to make this seem like the expansion of property number 5 so that I can factorize it to the form of x plus y plus z whole square. So when I get plus 12xy, I immediately write it as plus 2 into the x term, which is 2x multiplied by the y term, which is 3y. So far so good. For the next term, I have plus 2 into 3y into 4z. However, while I have got the exact terms over here, the sign is minus 24yz. This becomes plus 24yz. So which clearly means that either the term 3y or the term 4z is a negative one. Now, I'll just leave this to be minus 2 as of now, and we'll come back to this in a bit. The next one is plus 2, and I'll represent this as 2x into 4z. So I got the first and the third term here as well. The product of this term is 16xz. However, here as well, there is a minus sign. Now, I know that there is one of these is a minus sign and one of these two is a minus sign. The common one out here is 4z. So which means I can simply assume 4z to be the negative quantity, and by that understanding we know that this 4z whole square was in fact minus 4z whole square. We mentioned that it really means the same thing. And so if we write this as a factorization, we can say it is 2x plus 3y minus 4z the whole square. We'll move to the second part. The second part is 2x square plus y square plus 8z square minus 2 under root into xy plus 4 under root 2 yz minus 8xz. Now again, just by visual inspection, I know there are three terms x, y and z, three variables rather, sorry, and which means that I will be factorizing this in using identity number 5. And so I want to represent this polynomial in such a way that it mimics the right hand side of identity number 5. So out here, for the x square term, for now, I'm going to write this as root 2 of x whole square. Remember, this can be plus or minus, don't know yet. Second term is y square. The third term is 2 root 2 into z whole square, where 2 root 2 square is equal to 8. Now coming to the next terms, this is where it gets interesting. So I need to mimic the term 2xy here, so I'll write plus 2 into x, which is root 2x, and into y. Now I know there is a minus sign here, so I know one of x term or the y term has a negative sign. And you know what? Just by visually inspecting the last 3 terms, I know that this term and this term has a negative sign, and I know the variable in common is x. So in all probability, or rather there is no probability, surely the variable x has a negative sign to it. So which means this is in fact minus root 2x the whole square. And I can write it as minus root 2x out here as well. For the next term, I need to make it in the form of 2yz. So this is 2 into y. For z we have 2 root 2z. Whereas the last term will be 2 into xz. So we have plus 2. In our case, x is minus root 2x. Z is 2 root 2z. This gives us minus root 2x plus y plus 2 root 2z the whole square. That's the factorization for the second part. Now moving to the sixth question. The sixth question is asking us to write the following cubes in their expanded form. The first part being 2x plus 1 whole cube. Now we'll use identity number 6, which is our cubic identity, to expand this. So I get 2x whole cube plus 3 into 2x square plus 1 plus 3 into 2x into 1 square plus 1 cube. This gives me 8x cube plus 2 square is 4 times 3 12, 12x square plus 6x plus 1. The second one is 2a minus 3b whole cube. I'm going to use identity number 7 over here for my expansion. Using that, I get 2a whole cube minus 3 into 2a square, 2a whole square into 3b plus 3 into 2a into 3b whole square minus of 3b whole cube. Expanding the brackets, I get 8a cube minus 3 is a 9, 9 4 is a 36, a square b. Here we have plus 3 3 is a 9, 9 6 is a 54, ab square, and here we have minus 27b cube, and this gives us the expansion of the cube. The third part is 3x by 2 plus 1 whole cube. Here I'm going to use identity number 6 for my expansion again. So this becomes 3x by 2 whole cube plus 3 into 3x by 2 square into 1 plus 3 into 3x by 2 into 1 square plus 1 cube. Opening the brackets, we get 27x cube by 8 plus 27x square by 4 plus 9x by 2 plus 1. And if I take a common denominator here of 8, I get 27x cube plus 54x square plus 36x plus 8. Which is the expansion for the third part. The fourth part is x minus 2y by 3 whole cube. This is of the form identity number 7, and hence I can write this as x cube minus 3 times x square into 2y by 3 plus 3 times x into 2y by 3 square minus of 2y by 3 whole cube. Opening brackets, we get x cube we get minus 2x square y. Here, one of the 3's in the denominator gets cancelled. We have 4xy square by 3. And out here we have minus 8y cube by 27. Taking common denominator of 27, we get 27x cube minus 54x square y plus 36xy square minus 8y cube. And that completes question number 6. Moving on to question number 7, it's asking us to evaluate the following using suitable identities. And the first one being 99 cube. Now I'll write 99 as 100 minus 1 whole cube, and that way I can use identity number 7 to solve this. This gives me 100 cube minus 3 into 100 square into 1 plus 3 into 100 into 1 square minus 1 cube. So here it's 100 cubes. That means there are 6 zeros here. 10 lakhs minus 3 into 100 square means 4 zeros is minus 30,000 plus 300 minus 1. Nine lakhs 70,299. Now we can cross-check this by actually doing 99 cube, and for sure we will get the same answer. Now the second part is evaluating 102 cube, which I'm going to write as 100 plus 2 whole cube, and we can use identity 6 to expand it. So the expansion of x plus y whole cube is x cube plus 3 into x square y plus 3 into xy square plus y cube. This gives me 10 lakhs again plus 60,000 plus 1200 plus 8. Thankfully all are positive signs, so the calculation becomes quite easy, and we get 10,61,208 as 102 cube. The third part is 900 98 whole cube. This can of course be written as 1000 minus 2 whole cube. And we'll fit this in identity number 7. Give us 1000 cube minus 3 into 1000 square into 2 plus 3 into 1000 into 2 square minus 2 cube. Expanding this, I get that's a big number. Plus 12,000 minus 8. This gives us 9940, adding 12,000 minus 8 is 11,992, so I get 11,992. And that's the solution for the third part. Now, in lieu of time, I'm going to stop this video right here. From question number 8 to question number 16, I'm gonna probably create another video and give the solutions over there. In case you're looking for solutions after question number 7, then the following video is what you need. So thank you for watching this. Do leave a comment in case of any questions, any clarifications, and reach out to me on the email ID below for any other question. Thanks for watching.